Simple linear regression in Jamovi is a statistical method that can be used to determine and find out if there is a relationship between two variables. One of the variables is an outcome or a dependent variable, and the other variable is a predictor or an explanatory variable. The objective of the simple linear regression is to fit the best regression line into the data and then generate a regression equation, and from the regression equation it will be possible to predict the outcome from a given predictor. So the test will determine whether a predictor can predict the outcome. Here in Jamovi I have two variables. The first one is the age, which is a predictor or an explanatory or an independent variable, and an outcome, which is systolic blood pressure, which is a dependent variable and or a response variable. Both variables has been checked for normality, and the assumptions for performing simple linear regressions will be not discussed or explained in this video. To perform simple linear regression analysis and to find out whether the age can predict the systolic blood pressure, in the analyze section here, click on the regression and then select linear regression, and in the new window move the systolic blood pressure into the dependent variable and the age into the covariates. Spontaneously two tables are generated for linear regression. We'll visit this shortly. If we scroll down here into model builder and click on it, will not make any changes. For the reference level, no changes. And for assumptions or assumption check, tick on the normality test, check on the QQ plot of residual, and check on residual plot, and also Cox distance. For the model fit, click also and tick on the adjusted R square and the F test. For model coefficient, also check on the ANOVA test, standardized estimate, and confident or confidence interval for estimate. For estimated marginal means, no selection. Looking at the table generated from the outcome of linear regression analysis for the two variables, the outcome, which is systolic blood pressure, and the age, which is a predictor. Model 1 here shows that the R is 0.728, and the R represents the coefficient of correlation between the two variables, and the value is high, which indicates that there is a strong positive correlation between age and between the systolic blood pressure. Increased age will lead to increased systolic blood pressure. R square here is just the square of R, and it means that 53% of the variation in the systolic blood pressure, which is the outcome, can be explained by the predictor, which is the age. An if value is calculated and a p-value is given here, which is less than 0.05. Looking at the second table here, which is the ANOVA table, shows that there is a p-value of less than 0.05. This table tests the hypothesis that the slope is not equal to 0, and here it shows that the p-value is less than 0.05, so there is a relationship between the systolic blood pressure and the age. The third table shows the model for coefficient, and the first value here, which is the intercept, is equal to 86.2, and the slope is equal to 1.1. The 1.1 here value means that with every increase in 1 year of age, there is an increase of 1.1 in the systolic blood pressure. The p-value here is significant as it is less than 0.05. The plot here, which is QQ plot, shows that on y-axis is standardized residual and on the x-axis is theoretical quantiles. Residual plot here shows that there is deviation from the equality of variances. From the table here, a regression equation can be generated as the intercept is given and the slope is given here. If I click on the table and copy that table and insert that into Word documents, the regression equation is written as y equal to the intercept, which is the p0, and then plus the slope, which is the p1, multiplied by the x, which is the predictor. So y is the outcome and x is the predictor. So y will be equal to the intercept, which is 86.2, plus, and the p1, which is the slope, is 1.1 multiplied by the x. So this regression equation can be used to predict the outcome based on a given value for the predictor or the age. So this is the way to do simple linear regression analysis in Jamovi.